Okay, we're finished with descriptive statistics. And again, what is the purpose of doing descriptive statistics or finding out descriptive statistics? The main purpose of descriptive statistics is to actually understand or the sample, so to speak. Now, what is the sample? How many people have responded? What is the frequency that we had so many males, so many females? Like how many defaulted, how many did not default, what's their percentage? I'm just describing the sample. Like here we have how many went to high school, did not go to high school, or whatever. And at the same time, I'm also giving some averages in terms of means, all right, and standard deviations to describe the picture of the sample. Now, the next stage that we have to actually go to is now in terms of inferential. Now, what is inferential? Now, when we talk about inferential, we are trying to infer from the sample in terms of the population. All right. So now, if you look at the data file here, basically the data file is, here's the variable view, of course, and here's the data view. Here we have had 1,500 people responding to this questionnaire. And what did they do? They all actually filled out the questionnaire, and then we entered the data one by one. Now, this 1,500 people are only the sample. But what happens, how can we talk about the population from the sample? And this is what we need to understand about how can we infer about the population. And there are a couple of tests that we need to do in terms of inferential. Now, a very simple inferential test is this. Let me just show you. What we're looking at is we are looking at something called independent samples t-test. And you can have a look at your PowerPoint slides on inferential statistics, and it gives you some idea of certain outputs. Now, to carry on independent samples t-test, what we are looking at is we are comparing the mean of two groups between each other. Are they different or are they similar? All right. So you go to analyze, and you're comparing the mean. So we go compare means, of course. And what do we go to? Independent samples t-test. All right. Now, if you notice, this is the screen that appears. And when you talk about independent samples t-test, what I want you to understand is this. There is the test variable and there's the grouping variable. All right. Now, the test variable is, always remember, the test variable must always be either in interval or ratio. Interval or ratio. And the grouping variable must always be in nominal scale, full stop. There's nothing else. And again, you must have only two groups. So now here I can look at a question with only two possible answers of two groups. Here we got defaulted, previously defaulted, and you got to define the groups according to what we saw in the variable view. It was 0 for one group and 1 for another. Then I go continue, and I'll just show you this again. I'll just go reset. What did I do? I want to first find out which are the groups I'm comparing. So I want to look at people who have defaulted the loan and those who have not defaulted the loan, whether they are different, say in terms of age group. So I go 0 and 1. All right. Now, what is that I want to test? I want to find out, is actually their household income different for those who have defaulted as compared to those who have not defaulted. So this is my test variable. All right. So that's what I'm looking for. I want to find out the mean or the average household income, which is in thousands. Are they different for the people who have defaulted or not? Now you may ask me, why do I need to find out? Because as a banker, I want to find out what is the mean salary of those people who have defaulted. So I know I've got to be a bit more cautious with this group. And that's possibly one of the reasons. So I go here, okay. And voila, this comes out. I mean, can you imagine we trying to do this manually for 1,500 people? So how do we interpret this? Now the question is, this is the output file, and how you interpret this is this. You look at household income in thousands for those who did not default, there were 954, and those who defaulted, there were 548. And how were the means? Those who defaulted had a lower mean as compared to those who did not default. So what does this tell you? This tells you people with a higher income the chances of they defaulting were lesser. And we've got standard deviation and also standard error and all. But what I want you to understand is now looking at whether we can actually talk about this in relation to the population. Can I infer this in terms of the population if I go and select anyone by random for those who have defaulted as opposed to those who have not, that they would be different from each other? We know that the means here are different, but let's look at a certain test. Here it's called the Levene's test. If you look in terms of the Levene's test, here the value is 0.002. Now, the fact that here we're talking about equal variances being assumed. If it's 0.002, you go to the next column here in terms of the sig2 tail. Now, it so happens that both sig2 tails here are 0, 0, 0. Now, what does it tell you about 0, 0, 0? Now, when you're talking about statistical significance, all right, what you must understand is I'm just going to show you in a blank Word document. Now, for statistical significance, we want to ensure that it is always below 0.05. Now, when it's below 0.05, probability of chance or probability, okay, what happens is when you look at this as a below probability, there's a bit of a typo there. Now, what does this mean? What I'm trying to say is there's a 95% chance of this happening, 95% chance of this happening to the population. Because we must understand what we are doing is we are predicting from the sample to the population. Now let me take you back to the output here. What does the output tell me? The sig2 tail is 0.000. So if it's 0.000, that means it says a 100% chance of this happening. Why? Because it's not in terms of points. What you do is 1. It's got to be 1 minus the probability here is 0.000. So that means here we're talking about there's a chance of 100% chance of something like this happening. Now, if there is a 100% chance, that means we know for a fact from this output that if someone is got a low income, about 51,000, and if they want to take a loan, we got to be a bit cautious because there is a chance of them defaulting. And what are we doing? What is our basis? Our basis is in terms of the sig2 tail that we've found out there is a 100% chance of these means being portrayed in the population for those who do not default at 64, whereas those who default at 51. So all you need to do is only look at these two means first, if they are different. Number two, look at the Levene's t-test. If this is below 0.05, then go to the lower row. And as long as here it's below 0.05, you can actually assume that there is a statistically sorry about that, statistically significant difference between the two groups. And here the two groups are what? Here we're talking about one being default and the other not defaulting of the loan. Alright, so I want you to have now let's see if we can do another independent samples t-test. Alright, and this time I want to see in terms of compare means. I go independent samples t-test. Instead of household income, and we use something else. And again, let's look at, say, maybe years of employment. what's happening here? Again, it seems to be for those who, sorry, here's at current address, those who stayed in the same house for about 7.5 years, and those with the current address were 4. Like you see, you have here's the current address, okay? And for those who defaulted, yes, and not defaulted. Now, if you look at those who defaulted, they were in the current address for a lower period of time as compared to those who did not default. So what we can assume is if one lives longer in a particular residence, the chance of them defaulting are lesser. All right. And again, how do we know this? Because we look at this Levine's test, and we also look at the second column, second row here. It's 0.000. So there's a 100% chance of something like this happening. Now, what I want you to do is look at your questionnaire and see if you can actually do certain tests between things like gender, or maybe even if you pick up, say, an age group. All right, let's talk about, say, comparing means here, and I'm looking at, all right, I'm looking at, say, instead of the actual default, I'm going to look in terms of level of education. I'm trying to say, and I'm going to say groups here. I'm going to put level of education, and I'm going to say groups 1, because here you can specify the groups. Although there are 4 groups in level of education, let me say 1 and 2. All right, and what is happening here? All right, it's very interesting. It's those who did not complete high school were significantly different from those who actually completed high school. Now, let's see if I can take you to one more, and then we will I just want you to do one more, and then we can actually take this level of education again, but put it in terms of groups 3 and 2 and see what happens. Very interesting. Now, I want to close off with this because this is a very interesting finding, and I want to explain this to you in the next session. So let's just be a bit patient, because if you notice, the means are different, but the statistical significance does not seem to be below 0.05. All right, so it's a very interesting way to end this session with a bit of suspense that you can actually follow on the next session and discuss more about it.